All right, so the directions for all problems today are going to be to simplify the rational expressions. This is going to start with being a review from yesterday. So when I look at this, remember we had like an old method and kind of a new method to use. And so sometimes there's some discrepancy about, well, how do I know which method I should use, which one works best? So I chose 4 examples to review from yesterday. Again, if you're able to keep up with my speed of instruction, feel free to write as you go. If you're somebody who writes at an average or a little bit slower than average pace, I want you only to pay attention to your learning. Go back and watch the video and take notes at that time. All right, so first thing I'm going to do is I'm going to find the LCM of this. So x plus 1, x minus 1, and an x all by itself. This is the LCM. So when I look back to this problem, and I go, all right, so I need to find a common denominator. And once I've identified the LCM, I can do that. What is this missing? Well, I cover up what it has. It has an x plus 1. It's missing both the left side and the right side. So over here, I'm going to start this problem. I have x, x plus 1, and x minus 1. I cover up what it has. It has an x plus 1 in the LCM. This needs an x and an x minus 1. This top needs an additional x and an x minus 1. Well, it already has an x. And now I need to attach another x and an x minus 1. The middle has an x minus 1, so I covered up in the LCM. This is what it's missing. I need to attach this to the middle. So I'm going to attach an x and an x plus 1. The far right-hand side has a 3. Sorry, it has an x, excuse me, it has a 3 on top, a 3 on the bottom. So I cover up the x, or the denominator, and the LCM, and I can see what it's missing. This is what it's missing. Now, I could write this down as x plus 1 and x minus 1, but many of you will know that if you take this and you FOIL it out, you're left with x squared minus 1. Now, if you didn't know that, you'd write x plus 1 and x minus 1, and then you would FOIL it, but this is what you come up with. So what do we do next? Now I'm going to take and I'm going to go, I know this is the same as x squared. I know this is the same as just x. So when I distribute this x squared, I end up with x cubed minus x squared. Again, x times x is x squared. Distribute the x squared. Distribute the x squared. 1 times x is x. Positive x times x. Positive x times 1. Negative 3 distributed. And negative 3 distributed. So this is just the numerator. I'm going to combine like terms next. So this is the only x cubed, and I'm looking at x squared. I have a negative 1 and a positive 1. All right, they eliminate themselves. And I have a negative 3x squared. This is my only single x and my constant. All right, is it possible that this can be factored further? Well, I'm going to check. It may be done, or maybe I can go a little further. Let's just check. So I'm going to come off to the side and see, can I factor by grouping here? I'm not sure. So when I look at this, what can I factor out? An x squared. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Remember, I take whatever this is and I copy and paste it in back. And now ask yourself, do you know a number times x that gives you x? What times x is x? Well, that's a positive 1. Is positive 1 times negative 3? Is positive 1 times negative 3 a positive 3? No, positive 1 times negative 3 is a negative 3. What does that tell us? It tells us this can't be factored. So what do we do if it can't be factored? We leave it just as is. There's the numerator. I'm going to take the LCM and put it down below. And here's my simplified answer. Here's my simplified answer. Just to note, some students in the past say, well, can I write this as x squared minus 1 and put in parentheses? You sure can. Not required, but you sure can. That is example number 1. When you put this in your notes, whether it's now or later, please make sure that you are labeling everything. This is day 2. This is day 2 of rational expression operations, and this is example number 1. Example number 2. All right, so I can see that this could possibly be factored, so I'm going to come down below and factor it. 1 times negative 4 is negative 4. What multiplies to give you negative 4 and combines to equal negative 3? That'd be negative 4 and positive 1. I'm just going to check multiplies and combines. So x minus 4 and x plus 1. Okay, because the leading coefficient is a 1, I don't need to worry about doing bottoms up. All right, so I've factored the denominator of the left. The denominator of the right can't be factored. And now I need to find out what is the LCM. So when I look at these, I know I need to have an x plus 1 and an x minus 4. This is the LCM. Now how does that help us? I'm going to come back up here. So x plus 1 and x minus 4. On the left-hand side, it has an x minus 4 and it has an x plus 1. That means everything's covered. This side doesn't need anything, so I get to leave the 4 by itself. Now on the right-hand side, it has an x plus 1, so I cover up x plus 1 in the LCM, or the denominator, and I can see it's missing an x minus 4. So I need to attach an x minus 4 above. Now remember to take this negative 3, not just a 3, a negative 3, and I need to distribute to both items inside. 4 minus 3x, oh, be careful here, plus 12. So this is the numerator. When I combine like terms, I get negative 3x plus 16. Now what if you put the 16 first and the negative 3x second? It makes no difference. There's our numerator, the denominator, and this is the simplified answer of this expression. Simplified answer of this expression. That's example number 2. Okay. Example number 3. I'll give you a second to write it down. Okay, so when I look at this, a good question I had from a student from my second hour yesterday was, how do I know when this negative sign or subtraction sign is right in the middle? It's right in the middle, like at the same level as the division sign. Does it go at the top, the bottom, or are they both negative? It was an excellent question. The answer is we just push it to the top. We just push it to the top. Okay, so when I look here, this looks different than our last two problems because there's no factoring involved. And so when that's the case, I would refer to as like the new method. So here's how I would do this, the quick way. I would say, okay, 8 times 5 is 40 with an x squared. And that's where I push the negative up and I push the negative up. Now what do I do behind there? As a review, I take the opposite denominator and I raise it up. Opposite denominator and raise it up. Okay, negative 3 times 5x is negative 15x minus 16x. Well, that's negative 31x over 40. And by the way, we know that x squared is the same as going x times x. X squared means 2x's. And the only reason I'm writing it out this way is so that you can see that when I simplify, 1x on top gets divided by 1x in the bottom. And yes, we often say they just cancel out. But in reality, I've been trying to emphasize in the last day that really they divide and equal 1. So when simplified, I get an answer of negative 31 over 40x. Now you may be wondering, well, where does that negative sign go? Can it go on the top, in the bottom, or in the middle? Doesn't matter as long as there's one and only one negative sign. So it could go right in the middle, or it could be down below as long as there is only one. This is example number 3, a review from yesterday. Again, please make sure you have everything in your notes. I know we're going fast because it is a simplified Tuesday. If you need to go back and watch the video, that's fine as well. Example number 4, a really tricky one, very similar to a homework problem that was assigned yesterday. And so I can see in this problem it looks a little different than example 3, a little different. And so I'm going to rely on the LCM. So what is the LCM here? Well, I just want to show you that this is different than this, and this is different than this. So when I look at the LCMs, I'm going to write one on top there. So I have this one. I'm going to put parentheses so you can see them. They're kind of like separated. And that's the left side, and here's the right side, just so you can see they're separated. So what is the LCM? So how do I find a common denominator of these two? Well, I know they need to have a 3. Okay, got that. Need to have 1, 3. They need to have a single x, okay? And they need to have an x minus 1. That is going to be the LCM. Tricky one. So I'm going to put that down below. 3x and x minus 1. Then I come up above. Okay, this has a 3, so I'm going to cover up the 3. And it has an x minus 1, so I cover up the x minus 1. It's missing an x. That means the 13 on top I have to attach an x to. So the 13 on top needs to have an x attached to it. All right, so I'm going to move on to the right-hand side. It has a 3. I cover up in the LCM, or the common denominator of the 3. It has a single x, and I can see it's missing an x minus 1. So on top, I need to attach an x minus 1. Okay, I'm going to distribute. I get 13x. I'm only going to worry about the numerator now. Now, I could FOIL this, F-O-I-L, and if you haven't recognized these two, when you FOIL it, you get x squared minus 1x plus 1x minus 1. Front, outside, inside, last. And the middle two terms cancel. So this is plus x squared minus 1, plus x squared minus 1. This is what I have on front, this is what I have in the numerator. So if I put it in standard form, there's the first, the second, and the third. And this problem is simplified. Here's example number 4, simplified. Hopefully that helped to clarify a few things before we move on today. So I'm moving on to example number 5. Example number 5. Now, what's different about example number 5? Example number 5 is now going to start, we have only been doing adding and subtracting, we're now going to integrate multiplying and dividing of fractions or rational expressions. Remember, rational means something that can be written as a fraction, and expression means there's no equal sign that's visible. So how do I simplify this rational expression? Well, I start by looking at this, and I'm going to grab a piece of paper. And I'm going to take this right here, and I'm going to see, can I, in fact, factor this? This is the numerator of the first. So 6x squared minus 17x plus 10. Well, 6 times 10 is 60. I want two numbers that multiply to equal 60, combined to equal negative 17. 1 and 60, no. 2 and 30, no. Oh, 3 and 20 do work if it is a positive 3 and a negative 20. Does that work now? Well, 3 and negative 20 does give you a negative 17, but it doesn't give you a positive 60. It gives you a negative 60, so that doesn't work. 4 and 15. 4 and 15 work here, but not here. 5 and 12 work. If both 5 and 12 are negative, I get a negative 17. If they're both negative when multiplied, I get a positive 60. That means that this expression, this portion of the expression, I got to write it down here, can be written as x minus 5 and x minus 12. Now, it's really easy when you're trying to go fast here and you're trying to factor to forget if the leading coefficient is different than a 1, I need to put the 6 in this case underneath. 5 6 cannot be reduced, so I push up. I have 6x minus 5. 12 divided by 6 is 2. I'm going to take this expression and I'm going to replace it where this was. On the bottom, this cannot be factored, so I have the left fraction already taken care of. Now let's look over here, same concept. So I'm going to look here, and on the numerator of the second fraction, I'm going to go ahead and I'm going to try to factor it. 2 times negative 4 is negative 8. I'm looking for two numbers that multiply and combine. Oh, that's going to be, let's see here, a positive 8 and a negative 1. Combine and multiply. So x plus 8 and x minus 1. It's so important, as you can see, that you understand how to factor and do it fairly quickly. Again, leading coefficient is different than a 1. This reduces to x plus 4. This can't be reduced, so I push up the bottom number. There was some confusion in Unit 2. Now, which number do you push up? Is the smaller number the larger number? It's neither. It's whatever's on the bottom of the fraction. I'm going to take this expression. I'm going to replace it in the numerator. And I'm going to do now the same thing over here. Multiplies to equal positive 4. what two numbers multiply to equal positive 4 and combine to give you a negative 5? Multiplies and combines. X minus 4 and x minus 1. Remember, always check if the leading coefficient is different than 1. This reduces to x subtract 2. This can't reduce, so it pushes up. 2x minus 1. Okay, so I've done all of the hard work. That's like the grunt work. Now what do I do? Because the whole goal here, the verb you're asked to do, is to simplify. Okay, I want you to recognize that with multiplying, if I take a step back here and I just said, let's review how to multiply. And let's do something like really simple. Let's say I gave you a problem like 3/4 times 1/5. How would you multiply? Well, first, what I would do is I would ask myself, is this bottom number, can it be reduced with anything on top? So 4 and 3 can't reduce, 4 and 1 can't reduce. Same. Can 5 reduce with 1 or 5 reduce with 3? Can't happen. Once you've checked that, you just go straight across. 3 times 1 is 3, 4 times 5 is 20, and we're done. Why am I reviewing that? Because in this problem, we'll work the same way. We're going to multiply straight across the top. But before we do that, we want to first see, can anything on the bottom reduce with anything on top? So anything on the bottom can reduce with anything on top. So watch. This x plus 4, this part, I'm going to check it with anything on top. And if there's anything that's an x plus 4, I can only cancel out 1 on the bottom with 1 on top. So nope, not exactly the same, not exactly the same. Hey, these are the same. So when I use the word cancel out, remember, in reality, it's x plus 4 divided by x plus 4. X plus 4 divided by x plus 4. Because if I take this and do this the long way, and you don't have to write this out if you were keeping up with me, I kind of skipped a step here that I assume you may understand. If I said, hey, don't reduce yet, just multiply across. So I multiply these, I push them together, I multiply these, I push them together, and now we do this canceling thing. Remember, the word canceling, in reality, when we're working with division here, when we say cancel, really it turns into a 1. So I have an x plus 4 on the bottom and x plus 4 on top. And just like 3 divided by 3 is 1, we went over this yesterday, 5 divided by 5 is 1, well, x plus 4 divided by x plus 4 is 1. So yes, you see me crossing them out, but in reality, know that it turns into a 1. Okay, I'll go to the next denominator. There's an x minus 2 on the bottom, and then there's an x minus 2 on top. So again, although I'm crossing them out, know that they turn into a 1. There's an x minus 1 on the bottom and x minus 1 on top. So I'm crossing them out. Again, they turn into 1. And what am I left with? I'm left with 6x minus 5. Now, what do you have on the bottom? Some students in the past would put 0. That's not true. Remember, anything over the 0 doesn't work. You could put it over 1, because remember how these turn into 1, but anything over 0 would be undefined. So could your answer be left like this? Sure could. Would I be accepting of over 1? Yep, either one of these answers is totally acceptable. This is the simplified answer for this rational expression. That was example number 5. Example number 5. Put on to example number 6 now. Here is example number 6. Give you a chance to write it down if you're trying to keep up with me. Okay, example number 6 looks a little different than example number 5. There's no multiplying involved, but what I do see here is I do see this written in standard form, because it's x to the third, x to the second, x to the first, and no x's. And so I'm going to see, hey, with this, is there anything I can do? This looks like it may be an example of factoring by grouping, something you learned freshman year. We reviewed it again this year with factoring. So how do we do this? Well, I look at this number, it's the smallest, and I go, okay, are each of these divisible by, no. The next factor would be 4. Each of these divisible by 4, 4, 4, nope, not 4. What about 2? 2, 2, 2, no, not 2. And 1 is not going to reduce anything. So now that I only look at this portion, and in this portion, the highest number you can take out of the constants is a 4. The most x's you can take out would be an x squared. 4 times 2 is 8. I need 1 additional x to get x cubed. 4 times 3 is 12. I need 2 x's, and I already have them. Remember, whatever this is, I'm going to copy and paste it in back. Let's see if this is factorable. Is there a magic number I can take times 2x and get negative 18x? What times 2x is negative 18x? That would be negative 9. Now, if this is possible, is negative 9 times positive 3 negative 27? It is. What does that mean? Think of this as kind of a front half and a back half here. I write down what they both have in common, 2x plus 3. Then it's what's in front of the first parenthesis and what's in front of the back parenthesis. Nothing that I've done is wrong, but this can go a step further. And how can this go a step further? Notice that the 4 is a perfect square, the 9 is a perfect square. This is an even number, so it splits into x the first and x the first, and you have subtraction. So 2x plus 3, and then 2x plus 3, and 2x minus 3. So this is 2x plus 3 and 2x minus 3. And this 2x plus 3 already existed in front. This is the factored form of this. I'm going to write it down. Now I'm going to factor the bottom. What multiplies to give you negative 30 and combines to give you a 13? 1 and 30, no. 2 and 15, hey, 2 and 15 would work if 15 is positive and 2 is negative. Yes and yes. Multiply and combine. So what does that do? I'd have x minus 2 and x plus 15, because the leading coefficient is different than 1. Now it reduces to negative 1/5, and I'm going to divide, let's see here, they're both divisible by 5, so divide by 5 and divide by 5. Once I have the fractions reduced, I take the bottom number and push it up, 5x minus 1 and 2x plus 3. I'm going to write this expression down in the denominator. This is equivalent to this trinomial. The verb is to simplify. How do we simplify this? So I always start with the denominator. Is there any x, 5x minus 1 on top? Nope, so I can't simplify this. Is there a 2x plus 3? Well, here's the part that's tricky. Not only is there 1, there's 2, but I only have 1 on the bottom, so you get to cancel 1 on the bottom with 1 on top. It doesn't matter which one you cancel. Again, I'm using the words cancel, but in reality, I need to almost reiterate that it's dividing. So 2x plus 3 divided by 2x plus 3 is a 1. What are we left with? 2x plus 3, 2x minus 3 over 5x minus 1. This is the simplified version of this rational expression. Moving on to example number 7. Example number 7. And we're going to start, this will be part 2. Example number 7. Actually, I think I can get through this one. So let's get through this one. Okay, when I look at this on top, I can see that they're both have, okay, I can divide a 6 out. So I divide a 6 out. Not only that, I can say I can take 2 x's, a maximum of 2 x's out. What would I be left with? I'm going to make sure that there's clear division here. Well, I need to have an x here, so 6x squared times x is this quantity. 6x squared times negative 2 is this quantity. So I have factored the numerator. Now I'm going to go to the denominator. Now I'm going to have to take out a piece of paper here. 2 times negative 2 is negative 4. What two quantities multiply to give you negative 4 and combine to give you negative 3? I think we already did that one today. So x minus 4 and x plus 1, but be careful. The leading coefficient is different than 1. So x minus 2. And then this can't be reduced any further, so I push the 2 up, 2x plus 1. I'm going to take this and write this in this position. Now here's the tricky part. If you've forgotten how to divide fractions, the division turns to multiplication, and then we flip the second fraction. So this was the denominator, it now becomes the numerator. And now this numerator becomes the denominator. And instead of me just writing this down, I'm going to do this at the same step. So I can take a 12 out, and I can take a total of 3 x's. And I would need 1x plus 2. Let's check that. 12x cubed times x, that's good. 12x cubed plus 2, that's good. So what do we do here? Okay, well, I'm going to draw another big line here, and I'm going to switch the color so it stands out. I'm going to just push these together. And when I push them together, I'm going to expand. If there's any x's, like x squared and x cubed, I'm just going to make them a little bit larger. So watch, I'm going to expand it to x and x, and then I have x minus 2 and 2x plus 1. So I push it together. When we multiply, we go straight across. Down here, I'm going to start by writing x minus 2, 2x plus 1. Here's another 2x plus 1. And then I'm going to put this out front, and I have 3 x's, 1, 2, and 3. Now, why did I write it that way? Just so it's easier for me to see and simplifying. So I'm going to start here. Do I have any x plus 2 on top? Nope. Okay, I can't simplify. Here's an x, 2x plus 1, 2x plus 1. Divides to 1. X minus 2 and x minus 2. Good. So 1x with 1x. So again, these divide to 1. Divide to 1. 6 goes into itself, and divide by 6 goes into itself one time. Divide by 6, 12 divided by 6 reduces. So 6 over 12 reduces to 1 over 2. What am I left with? I have a 1 on top, only a 1. On the bottom, I have 2x and an x plus 2. All right, as we are almost done here, I need to go over what has changed from when I spoke to you yesterday. So stay with me. Please do not leave the class until I get done going over this. What has changed is that I thought this first Tuesday I was able to continue with live instruction in the afternoon. They don't want that live instruction to happen until next week. So for that reason, you will have a video to watch that will be about 15 minutes this afternoon, which means that I'm going to send it out to you in advance in case you happen to want to watch it before this afternoon. You can do that. And I will send out a homework assignment. And then what's going to happen is during our scheduled time when we are scheduled to meet this afternoon, if you have any questions, you're going to send me a private message. I can call you over Teams, and we can go over any problems that you are not understanding from the videos of the examples, or you're not understanding for the homework. Again, I've extended the homework date from yesterday. I'll extend it until tonight at midnight. So will you have an additional problems to do today for the lesson? Absolutely, you will. And I will send you the video for those in the next couple hours. That will be required for you. Now, can you watch it this afternoon during our scheduled class time? Yes, you can. Or you can watch it during your lunch or any time prior. Whenever it works for you, just know that today's homework, in addition to last night's, is based on this continued lesson or the second video I'm going to send you. If you have any questions, you're going to reach out to me.